Alright guys, so the first thing we're going to look at is problems 1 through 4. So there are questions on how we do 1 through 4, one of those that we want to look at. Well, this is all dealing with the nth root of a, so if we look at number 3, we're taking the 14th root of 16,384. And really at this point we can plug it into the calculator and we get what? 2. So 2 to the 14th is 16,384. So we can type that into the calculator and it would give us our answer. So any other questions or any questions on 1 through 4? Okay. Questions on 5 through 8. Well, how would we do any of these here? Yeah, we can plug these into the calculator. You can do 8 to the negative 2/3, and if we do this, we get 1/4. And this here would be 1/27. 1/9 to the 3/2. Because we can type these into the calculator and we would get our answer. So for any one of these here, we can just type these into the calculator and we would get our answer. Nine through 12 would be the exact same thing. We can plug these in and it would give us our answer. And it's asking us to round to the nearest 4th decimal place, so we just figure out, so we go 4 spots, we look at the 5th one, really. We look at the 5th decimal place. If it is 5 or greater, we round up. If it's 5 or less, we round down. So if we look at number 12, if we type this into the calculator, we would get 27.85761803 is what the calculator will tell us. That's the entire number. But it only wants to the 4th decimal place. 1, 2, 3, 4. So we look at the 5th one. Since it's a 1, we round down to 6, and that's it. And that's all we really need to do for, well, the first page. There's a lot of it, all the stuff on the first page is just typing this straight into the calculator, and we would get our answer. Okay. We can look at a few of these here. Simplify each expression using the properties of rational exponents. Well, for 13, powers of powers multiply. So we would do 3 times 1/4, which would be 3/4. So we'd have 6 to the 3/4. And that's all we have to do for this here, because we're not going to simplify it down from there. Now, if we look at 14, 9 over 12 will reduce, because they do have a greatest common factor of 3. Now, there's 2 different routes we can go from here. And the main route I would suggest is, because the exponent is negative, we can flip the fraction inside. Because one of our properties of exponents is that we have m over n to the negative x. It is the same as n over m to the x. Because our properties of negative exponents, if an exponent is negative, we have to move it from the numerator to the denominator, or denominator to the numerator, to make it positive. Whenever we move it above the fraction bar, it changes the sign of the exponent. So we could have done it that way there. Now, if we decided not to do it that way, and we applied it to both numbers, well, it'd be 3 to the negative 3/4 over 4 to the negative 3/4. Well, I need these exponents to be positive. So to make the 4 in the denominator positive, we have to move it to the numerator, which would make it 4 to the 3/4. And to make the 3 exponent positive, we'd have to move it to the denominator. and that'd be our answer. So we could flip it and then apply the exponents, and it would give us the same thing. Or we can do it this way here. Either way, we'll get the same answer. All right. We'll look at number 15. Now, one of the interesting things with 15 is that we have 2 to the 2/3, 16 to the 2/3, 4 to the 2/3. All of them have the same exponent, which means I can rewrite it as 2 times 16 over 4 to the 2/3. Is our quotient, this is combining a little bit of the quotient and product properties of exponents. And really, our quotient property says that if I have something being divided to a power, each one gets that power. The numerator and denominator get that power. But we can take it in the opposite direction. If all of them have the same exponent, we can pull it back out. Because it's really, our property is saying if m over n is to the x, it's the same as m over x over n over x. Because we've worked with it going that direction, but we can also go the other way because the exponents are all the same. We can pull it back out and have it in a set of parentheses. And yes, why would this be helpful? Well, if I look at this here, can I do 16 divided by 4? So do 2 times 16. Divided by 4. Because 8 plus 8 is, and 16 and 16 is 32. Now, say we did 16 divided by 4. What is 16 divided by 4? Times 2 is 8. We can get to the same place. Because since they're being multiplied in the numerator and not added, we could essentially have rewritten this as 2 times 16 over 4 to the... Yes, because multiplication, we can kind of rewrite it. Now, 8 to the 2/3, the 3 in the denominator of the fraction, in the exponent, tells me I'm taking what root? The third root. So I'm trying to see what number times itself 3 times is 8, yes? Is there a number multiplied by itself 3 times that's 8? 2 times 2 is 4, times 2 is... So I can take the cube root of 8, and it would be... And the 2 in the numerator of that exponent tells me I'm doing what? I am not square rooting it, but squaring it. Because really what we're saying is that I'm taking 8 to the 1/3 to the second. Because that's just essentially, we can break that fraction up. Because the cubed root of 8 is, and 2 squared is. Now, could I have plugged 8 to the 2/3 in the calculator? And it given me 4? Well, yeah, it's a whole number. Right, so on ones like these here, why do we go all the way out? Well, we have a whole number, yes? Now, earlier, because on 14 we had 3 to the 3/4 in the bottom of the fraction, yes? Does 3 have any factors? No. So there's not going to be any real way that I can take the 4th root of 3 and then cube it and get to a whole number. So we leave it here because it's not asking for approximations. It's not asking for us rounding. It's just wanting us to simplify. Well, this here, it does simplify down to 4, yes? If we get a whole number on these here, we get a whole number. And if you do have questions on the test, you can ask. I will tell you, do we need to take it all the way out and get an approximation, or can we leave it as with those numbers? Now this one here, because the bases are the same, 4 times 4, we can add the exponents together. So we can do 1/2 plus -3/2. Well, 1/2 plus -3/2. It'd be -1, because 1/2 plus -3/2, or 1/2 minus 3/2 would be -1. Yes. Now, because powers of powers multiply, we'd have -1 times -1/4. Well, -1 times -1/4, the negative and negative make a. And 1 times 1/4 is 1/4. Because powers of powers multiply. Mm-hmm. So this here is the correct answer. The answer key on the review sheet is wrong. I'll have to fix it. It should be 1/4, not 1/8. Yeah, I don't know why Pass Me messed that up. But oh well. But any questions on this so far? Okay. These are properties to simplify. Most of the ones of these here on the test are going to be, you can type them into the calculator. So we're not going to worry about too much of this here. These here, how can we solve these? The yellow calculator will do a lot of these for us. Because if we really wanted to solve them by hand, we'd have to multiply by its conjugate, the denominator's conjugate, which would be 9 plus the square root of 6, which would give us 99 plus 11 square root of 6 over 81 minus 6. We get 99 plus 11 square root of 6 all over 75. And we can plug these in, and I think we got the same thing. Mm-hmm. So it'll give us the same thing. Now, if we're having to do this by hand, I'm not going to make you do this by hand, but some professors might. You have to multiply it by its conjugate, the conjugate of the denominator. We're really just changing the sign between the two. Since it was minus, it's now plus. Because when we do the multiplication, we do get 81 plus 9 square root of 6 minus 9 square root of 6 minus 6, because the middle two terms will cancel. It's using our perfect squares. Yeah, our difference of perfect squares, our x squared minus 9, how it splits up into x plus 3, x minus 3, those kind of deals, to simplify the denominator. I want to come back to this here, and I'm going to check on those in a minute, because I want to get to some more of this here, this one for sure, and some of our solving. Because when we look at this here, it gives us this function. Now, before we look at this one specifically, are there any, do y'all want to look at 31 or 32? Which one specifically do you all want to look at? So we want to look at 32? Okay, so we want to do f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Okay, so f plus g of x. Well, that's the same as f of x plus g of x. Well, what is f of x? 4x to the 5/4. And g of x is 2x to the 1/2, yes? Are these variables the same? Are these like terms? Can I combine them? So am I done? Because that's all it asked for. Now, f of x minus g of x, f minus g of x is the same as f of x minus g of x. Now, f of x is still 4x to the 5/4 minus 2x to the 1/2. So can we combine these like terms? Well, there's not like terms to combine, so we can't combine anything. So at this point, we're done. Okay, well, that moves on to f times g of x, which is the same as f of x times g of x. Now, f of x, as we said, is 4x to the 5/4, and g of x is 2x to the 1/2. Yes? Now, this here, we can go on and multiply, because we can do 4 times 2, which is 8. Because x and x, they're the same base, we can add the exponents. So we'd have 5/4 plus 1/2. And if you're going to say that it's 6/4, that's not quite right, because the bases are not the same. Because for us to be able to add them, we need the bases to be the same. It would be 7/4. Use your resources. Because we'd have to change 1/2 into 4ths, which would be 2/4. 5 plus 2 is 7. And last but not least, we have division. F over g, f divided by g of x, which is just f of x divided by g of x. So f of x is 4x to the 5/4. G of x is 2x to the 1/2. So we'll focus on the numbers first. Can I do 4 divided by 2? Or would it simplify? It would simplify 2. 2. Now the variables we'll put out to the side because we're going to subtract the exponents. And it's going to work out here, the bigger exponent is on top. So we're going to have to do 5/4 minus 1/2. Now we already said 1/2 in fourths is 2/4. So 5 minus 2 is 3. And it would be positive. So that's our answer for division. Any questions on any of these here so far? Now, if the fraction doesn't simplify, so like 5/3, we can leave it as 5/3, and then we would put the x out to the side, just kind of like what you guys did on the homework. Y'all remember some of those? So you can leave it out to the side, or you can put it up in the numerator. The only reason it would be in the denominator is if it has a negative exponent in the numerator. Does that make sense? We cannot leave the exponents negative. Okay. Okay. I'm not going to worry about doing f plus g of 2, f minus g of 2, all of those there. I pulled that section off of the test. It's not because it's not helpful to know. It's just time consuming and it's going to take up a lot of the test, so I didn't include it. But we will have composition functions, f of g of x, g of f of x, f of x, these kind of functions. Is there one of these that we want to look at specifically? (41) g of f of g of f of g of 3. Now, when we looked at these here, where did I say that we should always start? Inside. We should always work from the inside out. Even though it has a whole bunch of them, really all I'm worried about to start with is g of 3. So I'm going to plug 3 into g of x. So g of f of g of f of, so I'm plugging 3 into negative 2x plus 5, so it'd be negative 2 times 3 plus 5. And I'm going to put a whole bunch. Can I plug negative 2 times 3 plus 5 into the calculator? Well, yes. Negative 2 times 3 is negative 6. And negative 6 plus 5 is? All right. Okay. Questions on this here so far? So again, we're still working from the inside out. So the only really thing I care about next is f of negative 1. So g of f of g of, well, f of x is 7x minus 2. Yes? So I'm going to plug negative 1 in for x. That'd be 7 times negative 1 minus 2. Seven times negative 1 is negative 7. Minus 2 is negative 9. I'm just rewriting those down so I still have them. So any questions on this so far? So we've just been plugging that number into whichever function it is. Now here we have negative g of negative 9 is what's next. So we'd have negative 2 times negative 9 plus 5. Well, again, we can type that straight in the calculator. Because negative 2 times negative 9 would be 18. And 18 plus 5 is 23. Okay, well now we have f of 23. So it'd be 7 times 23 minus 2. Seven times 23 should be 161. 150 and minus 2 would be 159. Yeah, I was doing it in parts. 7 times 23 would be 161. Minus 2 would be 159. And you can just do 7 times 23 minus 2 in the calculator, and it'll give you 159. Well, wait a minute. How many functions do I have left? 1, yes? So I need to plug this into g of x. That'd be negative 2 times 159 plus 5. Type it in. I have a feeling it's going to be negative. And that's our answer. So no matter how scary these composite functions look, always work from the inside out. Do it one step at a time. So any other questions on these composite functions or any other ones that we want to look at? Now, it doesn't matter if we have g of x or f of x or f of g of x. Any of these are going to go the same way. So if I look at f of g of x, the first thing I'm going to do is I'm going to plug x into g of x. Well, that's not really changing much because it already has x there. So it'll be negative 2x plus 5. Yes? But it's going to be different for f of x because I don't have f of x anymore. I have f of negative 2x plus 5. I've replaced x with negative 2x plus 5, yes? So in f of x, I'm replacing x with negative 2x plus 5. So it should be 7 times negative 2x plus 5 minus 2. Now we can distribute the 7, which would be negative 14x plus 35 minus 2, which would be negative 14x plus 23. And I know I went through that pretty quick, but it's just multiplying through by 7 and combining like terms. Any questions on this here? Okay. Okay. Let's look at least one of these here, finding the inverse. Why don't we look at 43? So when we do any of these here, our steps follow the same path. If I want to find the inverse, the first thing I need to do is I need to replace g of x with y. Now, it doesn't matter if it's g of x, f of x, h of x, z of x, q of x, gamma of x. I mean, it's just a function. And it's just taking the place of y. So we need to put y back. Now, our next step was to switch x and y. Because if we're finding the inverse, it's really we're switching the input and output of the actual function, so we're switching the x and y. And now we need to get y by itself. Okay? Now, whenever we do this, again, order of how we look at trying to get y by itself is going to go addition, subtraction, multiplication, division. Powers and roots are always last. Okay? So if I'm looking at this here, what would be the first thing we would want to move? The minus 7, because we can add 7 to both sides. Because we'd have x plus 7 equals 2y cubed. Bless you. What can we do next? We can divide by 2, because we don't have any other addition subtraction we can do to get y by itself. So we go to division. So we'd have x plus 7 over 2 is equal to y cubed. Almost. Not square root, but cubed root. You're good. We would cubed root both sides, which would tell me y is equal to the cubed root of x plus 7 over 2. And that would be it. Now, could we go back and do addition, or are there some that we have to do powers first? Yes. Because if the whole thing like this here, if we were finding its original function, or if this was the original function, we were finding the inverse, we'd have to start out with exponents because the cubed root is trapping everything inside. So sometimes, because looking at this here, this final product, I can't do addition, subtraction, I can't do multiplication, division, I have to do powers first. And then I can go back. So we can redo those orders as we go through it. Questions on this here? Mm-hmm. Yes. Okay. We good? Okay. Now the last thing I want to look at is solving. Solving these here, solving these radicals. Now whenever we solve a equation with radicals in it, the first thing we really need to do is to get the radical by itself. We need to get the radical by itself. Because once we get the radical by itself, then we can put both sides to the nth power and solve for the variable. So let's look at 44. Is the root by itself? Well, yes, there's nothing else with the square root of 2y. Everything that's on that side is all inside the root, so we're good. Which means I can square both sides. Because the square root and square would cancel out, leaving me with 2y is equal to 8 squared is 64. Then what would we do? We divide by 2 because we want to get y by itself, which would tell us y is equal to 32. Now, if it says check your answer, if it says in the instructions, check your answer, check it, which would be 2 times 32 equals 8. I mean, plug it back in and kind of show that you've done your work, or kind of checked your answer. Because one, it helps to make sure you got the right answer, because if it is the right answer, it will work out. And really, I could plug in square root of 2 times 32 in the calculator, hit enter, and it should give me 8. If it doesn't, it's kind of a good way to say, hey, this answer isn't right. And especially if it says check your answer, there's a chance there might be an extraneous solution, especially if we get more than one. Will there be a no solution on the test? Yeah. Is there going to be one? Have I put no solutions on the test? No, because I'll put them on the review sheet, I'll put them on the homework, but on the test, I know for most of y'all, your first thought is not, oh, it's a no solution. It's more, no, I did something wrong. So I don't like putting them on the test because it's not something that you're used to thinking about. So I exclude those off the test. The only way I will include it is if I pretty much blatantly am projecting that something could be a no solution, but there's not going to be one on this test. Okay? So questions on this here. Now, 45. Let's see here. 45, 46, 47. Let's look at 50, because 50 is a little bit different. Because I feel like for the most part, y'all feel good with those there, getting the radical by itself. Yes? No? Maybe? If we look at 50, is the radical by itself? Yes. So what we can do is we can square both sides, because the square root and square will cancel, leaving us with, that'd be good if I, all right, 3 minus s. But on the other side, we have s minus 1 squared, which is the same as s minus 1 times s minus 1. Well, we're going to have to multiply this out. Well, s times s is s squared. S times negative 1 would be negative s. Negative 1 times s would be negative s. And negative 1 times negative 1 would be plus 1. Now we can combine like terms, because negative s minus s is going to be negative 2s. Negative 1 minus 1 is negative 2. So I have an s squared, which means this is a quadratic. We need to get everything on the same side. So I can do that by adding s to both sides. So we get 3 is equal to s squared minus s plus 1. And then what can we do? We can subtract 3 from both sides, which will give us 0 is equal to s squared minus s minus 2. Any questions on any of this here so far? Now at this point here, we can factor it. Since 2 is negative, our signs are opposite. The factors of s are going to be s and s, and our factors of 2 are just 1 and 2, because those are the only factors of 2. Now, which one would be positive and which one would be negative for the factors of 2? 2 would be negative, 1 would be positive. Now, because we have two things multiplied together that equal 0, it means that either s plus 1 is equal to 0 or s minus 2 is equal to 0. One of these two is going to be 0. At this point here, we'll solve both of these. So we try to find the value of s. So we get s is equal to negative 1 and s is equal to 2. Now, especially on these here, this one here, because we have a variable outside of the radical, we need to check it. We need to check it, this one for sure. So we can start off with negative 1. Because we have the square root of 3 minus negative 1 is equal to negative 1 minus 1. Well, negative and negative make a positive, so 3 plus 1 is 4, but the square root of 4, which is 2, is not equal to negative 2, so s would not equal negative 1, because it would not work in the original problem. Now we can try 2. 3 minus 2 is equal to 2 minus 1. Well, 3 minus 2 is what? 1. Square root of 1 is 1. So for s equals 2, it would work. Any questions on any of these here? Do we want to see more examples of solving? Okay. Yes. So we do want to see at least one or two more of solving. Okay. So since that is the case, and because we have 3 minutes before the bell, put it on the other screen. We are going to finish the review sheet tomorrow. Because I could